last but not least, I want to mention something extremely cool, namely everything that we learn about second-order ODEs can be naturally written as systems of differential equations. In other words, if you know how to solve systems of ODEs, somehow you'll also be able to solve all second-order ODEs. And in particular, let's try to write y double prime plus 4y equals 0 as a system of ODEs. And it's just based on this little trick. So we need two functions. We need a x1 of t and then a x2 of t. Now, x1 of t, well, one idea is to use our function y. And then what about x2 of t? How about we use the derivative? And remember, systems means find the derivatives of x1 and x2 here. So then, well, x1 prime, that is just y prime. And x2 prime becomes y prime prime, so y double prime. But we want to write this in terms of x1 and x2. Well, y prime, that's just x2. What about y double prime? So we want to write this in terms of x1 and x2. So in terms of y and y prime, well, what helps us here is our differential equation. Because what this is saying is y double prime is just minus 4y. So here you use the ODE. So this becomes minus 4y, and that becomes minus 4x1 of t. So you see, we have this closed form system, and then we just want to write this in terms of coefficients. So x1 prime of t is something x1 plus something x2. And then x2 prime of t is something x1 plus something x2. What are the coefficients? So x1 prime is x2. That's no x1 and 1 x2. And x2 prime is minus 4x1. That's minus 4x1 plus no x2. And so what we end up getting, we then get x prime equals ax, where a is 0, 1, minus 4, 0. And I will actually ask you, I think on some homework assignment, to solve this second order ODE using systems. And the way it works is as follows. You would solve for x of t. You will find some concrete solution x of t, which is x1 and x2. And then what is your solution y? That's just x1. Then in fact, y is x1, and you will actually be able to see that this gives you a cosine of 2t plus b sine of 2t, which is really cool. So once again, you find the solution x of t, and you just look at the first component, and this gives you y, and the second component gives you, turns out, y. Now, the cool thing is, so surprise example, we can do the same thing, not just for higher order equations, but also for inhomogeneous equations. So let's do the same, but for y triple prime minus 3y double prime plus 3y prime minus y equals t squared. Same trick as before. Here we need 3 unknowns because it's a third order equation. x3 of t. Well, x1 you can use y, x2 you can use y prime, and then for x3, well, we need another one. Let's use y double prime. And then what we end up getting, x1 prime becomes y prime, so that's x2. x2 prime, that is y double prime, which is x3. And x3 prime, that's y triple prime. But again, now we can just use the ODE. ODE, which tells you this becomes 3y double prime minus 3y prime plus y plus t squared, which again becomes 3 x3 of t minus 3 x2 of t plus x1 of t plus t squared. And remember, we need to put everything in order. So x1 prime, x2 prime, x3 prime. Unfortunately, the order matters in systems. So you want to write this in terms of x1, x2, x3. I know, very long, but very powerful. x1, x2, x3, and then x1, x2, x3. Oh. Okay. Now, what are the coefficients? So x1 prime was x2. So 0x1 plus 1x2, 0x3, and then 0. x2 prime was x3. So 0, 0, 1, and then 0. And then careful, x3 prime was this, which was 1x1 minus 3x2, 3x3, and then the inhomogeneous term. So what this gives you in the end, we just have x prime of t equals ax of t plus f, where a is all those coefficients 0, 1, 0, 0, 0, 1, and 1 minus 3, 3, and f of t is, I think, not 007, but 00t squared. It's the mathematician cousin of James Bond. And again, what's cool about this is it's an example, not just of an inhomogeneous system, but of a 3x3 system of equations. And you may wonder what's next. Well, I already told you that we need some linear algebra to solve systems of differential equations. So the next lecture is a bit of a linear algebra review.